A ratio is just a comparison between two quantities. We're going to do a lot with this over the next week or two. So a ratio is just something like 5/7. Could be written as a fraction. Could be written with a colon, like 1:2 means the same thing. Or it could be written with the word 2, 1 to 2, comparing things. A proportion. Proportion sets two ratios. Can't spell ratios. That's probably spelled wrong. I don't know. Equal. And I'm going to write it this way, and I want you to write it this way in your notes. This is called the first term, second term, third term, and the fourth term.
You like the Beastie Boys, Mr. Ebersole?
Is that who this is?
Yes.
When we're doing this, first term, second term, third term, fourth term, if it's written that way, that's fine. It could also be written using ratios, so it'd be first term, colon, second term, did I say ratios? Could be written using colon, did I say that? Did I say it right? Equals third term, colon, fourth term. Just a different way to write it. The extremes. The extremes, if you got your first, second, third, and fourth, which ones do you think are the extremes?
1 and 4.
1 and 4. So write that here for extremes. First and fourth terms. First and fourth terms are called the extremes. First and fourth terms are called the extremes. And which terms do you think are the means?
The middle. Second and third.
Second and third. So the first and the fourth are the extremes. The second and third are called the means. When you dealt with proportions in the past, when you did them in 5th grade, 6th grade, whatever, they taught you to make the little butterfly probably, or circle, cross multiply, right? Well, that's the actual way to solve a proportion is by multiplying the extremes together and multiplying the means together. Now, they didn't teach you all that in 4th grade, 5th grade, whatever, because they probably didn't figure that at that point you would completely understand it. So they just told you to make the little butterfly to solve it. An example, a hockey player, and I think on these, I think I screwed up when I printed off. There's not a whole lot of room there. It didn't take a whole lot of room to do these, but it's sort of a little messed up. A hockey player scores 9 goals in 12 games. Find the ratio of goals to games. So if we're doing goals to games, what goes on top? What number? 9. What goes on bottom?
12.
That's your ratio. It's that simple. All right. Now, if you wanted, you could reduce that. I know how much Logan loves to reduce things. So if you use your calculator, you can reduce it. If you got 9/12, you just go on your calculator. Anytime you're wanting to reduce anything, you got 9. Use the ABC button or whichever button you happen to have on your calculator. 9, ABC button. ABC button 12. I pushed the wrong button like 10 times. And then if Logan hits equal, what's it tell you, Logan?
3/4.
It'll reduce it for you. There's nothing wrong with leaving it as a non-reduced fraction. Even though your third grade teacher or whatever told you that never ever leave it that way, there's nothing wrong with it. Especially when we're doing stuff like this. Next one, to solve a proportion. We're going to solve this proportion together. As far as the little butterfly thing goes, you won't see me draw the circles very often. I just do this. I draw, my pen would work. I just draw little lines. I want to multiply those two. The first thing, anytime you have a problem like this, the first thing you want to do, put parentheses around that. So if it's got more than one term or more than one number or variable in a term, put parentheses around it to start with. So then when we go to solve it, we're going to take this times that, so I'm just going to write it 5 parentheses, x minus 2. Don't forget your equals. A lot of students always forget to put their equal sign in between, and then we cross multiply the other way. Again, if you want to do the little circles, do the little butterfly, whatever, that's fine. I just usually just do little lines to show what we're multiplying. What do we get when we multiply this way?
8.
Then how are we going to solve that? Distribute. What's 5 times x give you?
5x.
5 times a negative 2. Negative 10 equals 8. What do we do first to start to solve that? A lot of our proportions won't be this difficult, won't have more than just a couple of steps, but this one, just to show you how to do these kind. Add 10 to both sides.
And divide 5.
So that gives you 5x on the left. What's on the right?
18.
18. Divide both sides by 5. Those cancel out. You're left with x equals what? What is it? 3.6. Now, there's nothing wrong if it doesn't come out perfectly even. Nothing wrong with leaving it 18 over 5. All right? 3.6 is all right because this one sort of comes out even after you divide it out one to the tens place. You could change it to 5 3/5 also as a mixed number. Or not 5 3/6, 3 3/5. 3.6, same thing. All those answers are sensible for this problem. Let me erase all this so we can see this one. On this one, anytime you see a problem like this, always put variable, we talked about this earlier this year, with each number. Whenever you see a problem that's got a ratio like 9 to 8 to 7, it's got a ratio like that, every single time you're going to put a variable with each one of those numbers. So instead of just having 9 here, that's actually going to be 9x, or whatever variable you happen to pick. That's going to be 8x, and then the other one's going to be 7x. The ratio of the measures of the 3 sides of a triangle is 9 to 8 to 7, and its perimeter is 144 centimeters. Find each side. I'm going to draw just a triangle up here, it doesn't matter what it looks like. This side, we just let it be not just 9, but 9x. This side, 8x. This side, 7x. How do you find the perimeter? We just got done doing this. Add up all the sides. So this time, what are we going to add up?
9x.
9x plus
8x.
plus,
7x.
and I'm writing it up here just so I don't have to bend down.
Equals 140.
And they told us the perimeter is 144, so equals 144. How many x's do you have? Do not tell me 3. 24? Are you getting ready to do that, Braylon? Is that why you were chuckling? Divide both sides by 24. Somebody help me out. What's x equal?
6.
6?
Yep.
So if x is 6, is that what it asks us to find?
No.
So find each side. Again, just we got done doing those real world problems. Do the same thing here. Make sure you go back, read the problem, know what they're asking you for. If x is 6, how are we going to find each side?
Times every side by 6.
All right, so just plug in 6 in all these. So let's do 7 times 6 first. What's that? 42. So that's one of the sides. 42 centimeters. How about 8 times 6? 48 centimeters. And 9 times 6? 54 centimeters. Those are the 3 sides of the triangle. How long now? We may have skipped this, so I'm going to say this just real quick. You might want to write it down in your notes there somewhere. This is a rule about triangles. Any 2 sides of a triangle must add up to, I think we did this, more than the 3rd side. Yeah, I'm pretty sure we did it because I remember putting on the board up here. And I told you, I probably told you that I'm not allowed to do it anymore, but I said, all right, draw this triangle and I'll give you an A for the rest of the year, and it's not possible. So whenever you know that any 2 sides of a triangle got to add up to more than the 3rd, you can look at these and just make sure that your triangle makes sense. So in other words, if we would have done this problem and we came up with our triangle and it was 1, 54, and 48, we know something's not right. That can't be a triangle. Because 1 plus 48 is 49, and that's not more than 54. So it's impossible for that to actually be a triangle in our world. In Andrew's world, it might be possible. In our world, it's not. Ratio of the measure of 3 angles of a triangle is 5 to 7 to 8. Find each angle. What are we going to set up for this?
5x plus 7x plus 8x equals 1.
I'm going to write it up here if that's all right. 5x plus 7x plus 8x. Just put an x with each one of those numbers. What do we know about 3 angles of a triangle? Add up to 180. How many x's do we have? 20. So 20x equals 180. Now what? Divide by. What's that leave us with? So x equals 9. Is that our answer? We take each of these numbers and multiply it by 9. What's 5 times 9? So one angle is 45 degrees. What's 7 times 9? 63 degrees. What's 8 times 9? 72 degrees. Somebody do me a favor real quick. All 3 of those should add up to how much? Check it out and make sure. No. Did it work out?
Yes.
On this one, watch closely on this one, a little tougher. Put parentheses around those two. We're going to cross multiply. When we cross multiply this way, we get 3x minus 1, parentheses, x plus 2. When you cross multiply this way, you got 2 times negative 2. What's that give us?
Negative 4.
Ebersole. I love this class so much.
Now what?
Foil.
Now you do FOIL. Remember your algebra days?
Yes.
3x times x, what's that give you? Times 3x squared. First terms, outer terms, 3x times 2 gives you what? 6x. Inner terms, negative 1 times x gives you negative 1x. Last terms, negative 1 times 2 gives you what? It's negative 1 times 2. Negative 2. Now, whenever we have a problem like this, several different ways to do it. One of the ways is factoring. Another way is using the quadratic formula. All those things. You're all right.
You split them. Start carrying.
Regardless which way you use, we need to move this negative 4 over here, and we'll simplify all the rest of this. The 3x squared stays the same. What's 6x and a negative 1x give us?
5x.
So positive 5x. If we move that 4 over, it becomes a positive 4. What's a positive 4 and a negative 2 give you? Positive 2. What's left on the right-hand side over there if we move the 4 over?
Nothing.
Nothing, which in math we say is 0. Does anybody remember the quadratic formula?
Oh my gosh.
Probably not. So then we got to factor it. We might figure out the quadratic formula and write it up here. If you have Mr. Harrison, I know he's had it on his wall for, whenever you had him, he's had it on his wall for the last 20 years or whatever, ever since he's
It's
worked
like
here.
minus x, and then it's like the square root of something. But I don't remember the rest of
So we're going to factor this. We're going to factor this. Factors of 3x squared. What times what will give you 3x squared? We just did it up here, probably about the only ones that'll
that.
work.
3x and x.
So in the first spots here, you put 3x and x. Okay, you can sort of remember factoring from algebra. Wasn't any fun, was it?
Nothing about fun.
Then we find the factors, so you find the factors of the first term, which were the 3x squared. Then you find the factors of the last term. What are the factors of 2?
1 and 2.
Positive 1, positive 2. What else could work?
Negative 2 and negative 1.
Negative 2, negative 1. Here we have all positives, so we probably want which one? The positives. Now the bad thing over here is it could go plus 1, plus 2, or it could go plus 2, plus 1. Which way do you want to try it? This is why none of you probably like factoring, because you got to guess, check it out. If it doesn't work, you got to go back and guess something different.
Do
What do we want to put first, the 1 or the 2?
plus 1.
Plus 1. Everybody all right with that? Might not want to write this down yet. See if it works first. Now to check it, we do FOIL again, but all we do is the outer and the inner. And we see if it gives us this middle term right here, positive 5x. What's 3x outer terms? What's 3x times 2x? 6x. I'm going to write that right here. Inner terms, what's 1 times x? What's 6x and 1x give us? Is that what we have here?
No.
So what's that tell us?
What's the other way?
It's the other way, or we got to try something different. I'm going to take my eraser here and I'm going to erase this, I'm going to erase that. This time we got sort of lucky because there was only one guess. So what am I going to put here? 2 here. So this one didn't work. Outer terms, 3x times 1 is what?
3x.
3x. 2 times x is 2x. What's 3x and 2x give you? That's what we have in the middle there. So that's our factored form. Anybody remember how to solve it once you get it to that point? If I got these two things here, I got this marker in my pen, and I say multiply together, they give me 0. What's that tell you about one of them?
1, 0.
One of them has to be 0, right? So here, if we had this set of parentheses and this set of parentheses, and we're multiplying them together, and it equals 0, one of them has to be 0. So all you do is you take the first set of parentheses, 3x plus 2, you set it equal to 0, or the second set of parentheses, x plus 1, you set it equal to 0. Remember all this. Those two equations, hard to solve? Not really. Pretty easy. These are the basic ones you did at start of algebra last year. Once you get to this point, what's the first thing you do here to start to solve this first one? Subtract 2. Those cancel out. Leaves you 3x equals negative 2. Then what? Divide by 3. Don't grab your calculator. Is 3 going to go into negative 2 evenly?
No.
So just leave it that way. X equals negative 2/3. Just leave it like that. Don't change it to the decimal, which is negative 0.6666. It just messes up the whole problem. So our x is equal is either negative 2 or, how do we solve this one? Just minus 1 on both sides. Those cancel out. What's x equal here then? Negative 1. So we're not sure, depending on the problem, we're not sure which one x is, but it's got to be one or the other of those two. Here it doesn't really matter. Here it's both answers because we didn't really have a normal real world problem. If you did have a real world problem, what you probably have to do with them is take both answers, stick them back in, and see if they make sense in the problem. A lot of times they won't make sense. A lot of the stuff, like when we were doing Pythagorean's theorem, if you came up with a negative when you were using Pythagorean's theorem, you know something was wrong because that answer had to be the length of a side of a triangle, and the negative won't work. Fill in what you need to fill in on this. We've talked about this before. Just going back over it again. A congruency transformation, that's like when we did the slides or the rotations. One shape, the original shape's going to be exactly the same as the new shape. Or the image is going to be the exact same as the pre-image, what you started with. Similarity transformation. Anybody remember which transformation did we use that had a similarity instead of a congruency? When you made something bigger or smaller, what was that called? Dilation. All right, so when we do a dilation, a lot of what we're going to do is just comparing these things, so they're just going to be similar. Congruent figures are figures with the same shape, same size. Remember the congruent symbol, the little tilde, the little curly cube with the equal sign. All right, then similar is just the little tilde. So that's what we're going to be dealing with, is that bottom thing there. Triangle ABC is similar to triangle KJL. Now it works out the same that when we say that these two triangles are similar, just like when they were congruent, if I tell you angle A is 70 degrees, what angle in the other triangle has to be 70 degrees? K. When they match up that way, the angles still have to be congruent, and I believe that's what the next slide says. All right, fill in what you need to fill in on this. K stands for scale factor. I wrote that in. You might write it in above it. That's up to you. There's nothing to fill in. I filled it all in for you then. Just might write down that K stands for scale factor. I promise Grace I won't eat in the back there. Remember scale factor, we talked about this earlier this year. Image length over the actual length. So your new length over, and you might want to write that down, new over old or original. Looking at our picture here, which one's the new length and which one's the original length?
8 is the old one and 12 is the new.
So this is the old, this is the new. So what goes on top? 12, what goes on bottom?
8.
That's your ratio, that's your scale factor. If you wanted to reduce it down, you could. You don't have to. If you do reduce it down, oops, it's not 4. 3 to 2. How about the scale factor in this next one? What's the new length? 18, so that goes on top. Over 30. Again, you could leave it that way. You could reduce it. Anybody know a number that will go into both 18 and 30?
6.
6 would go into 18 how many times?
3.
Into 30?
5.
Oops, wrong way. So on this one, did we enlarge it or reduce it? Reduction. This one we enlarged, and you can always tell by looking at the top number and comparing it to the bottom number. Top number is bigger than the bottom, you're making it bigger. Top number is smaller than the bottom, you're making it smaller. And that's what this part says. Fill in what you need to fill in on this. Lena's probably getting mad because we filled in a whole bunch of this just a couple of weeks ago. Remember all of it. It's on the next page, I think. Yeah, that's it. I think that's it. Yeah, it's just a little different. Looks a little different on your paper. Top part there we already wrote down, so. Again, enlargement. For an enlargement in your fraction, you're going to have big on top, small on bottom. If you're enlarging it for a reduction, you're going to have small on top, big on bottom. If your scale factor happens to be 1, then that means you're not changing the size at all. It matches up exactly the same. Dilation, again, we talked about dilation, is a non-rigid motion, and these two things down here at the bottom, you remember back when we did this sort of thing a while back, I just stuck them in there just to make sure you remember it. To change a fraction to a decimal, you just divide. To change a percent to a decimal, you always bump the decimal 2 places to the left. If you wanted to change a decimal to a percent, you bump it 2 places to the right, so on and so on. All those things that you should have learned in 6th grade, 7th grade, somewhere.
Do the trail that teaches that here, sure.
Yeah, they do.
No, that teaches in middle school. Nothing.
You're making your own photo stickers. Your photo is 4 inches by 4 inches.
That's pretty big.
The image on the sticker is 1.1 inches by 1.1 inches. What is the scale factor? So we're going, this is the original photo. This is our sticker. So what goes on top? Which one is the new one? The sticker. So that's what number goes on top? 1.1. What goes on bottom?
4.
That's your scale factor. Now, Andrew doesn't like that because it's got that decimal in it. This is what you can do to it. To get rid of that decimal, how many places do we got to bump the decimal over in this top one? Right, 1. So if you do that on the top, you got to do it on the bottom. So what are you going to do on the bottom? Right, 1. What's going to get added there? 0. So on top we got 11. On bottom we have what? So our scale factor is 11 to 40. So for every 11 units in the sticker, there's 40 units in the real picture. Similar, find this on there, fill it in. Again, similar polygons have the same shape, but not necessarily the same size. So my purple and my green triangles here are the same shape and the same size, so they're congruent to each other. All right? My green triangle, my blue triangle are the same shapes, but they're not the same size, so they're similar to each other. Again, this is the symbol for similar. So this says Pentagon ABCDE is similar to QRSTV, Pentagon QRSTV. When you're dealing with similar polygons, whether it's a triangle, most of the time we're going to be dealing with triangles. That's what we're going to deal with the most. But it could be any polygon. 2 things have to happen for things to be similar. Corresponding angles are congruent. So the angles still stay the same. So if I'm looking at these 2 pentagons right here, even though they're not congruent to each other, they're just similar to each other, the angles that match up, like angle T and angle B right here, are the same measures. So if I have 2 triangles that are similar, and this angle is a right angle, then that tells us this angle right here has to be a right angle. The angles don't change. You look at my blue one and my green one here. In the blue triangle, that's a right angle. In the green one, that's a right angle. Now hopefully you guys know by now. Anybody have a guess what the measure of this angle is? 45. So what's this angle going to be? 45. What's this angle? 45. This angle, 45. So in similar polygons, the corresponding angles, the angles that match up, are still congruent to each other. The corresponding sides are proportional. So all that means is that if we know one side compared to a second side, compared to the side in the other triangle, compared to a second side in the other triangle, they're going to be proportional to each other. We're going to be able to set up a proportion and solve our proportion by cross multiplying and doing all that. Somebody name this first. What is that? 1, 2, 3. A pentagon. Somebody name that pentagon for me. Does it matter where you start at? So pick a letter. Then what? Now, what does matter is you have to go around it in some kind of order, right? So if we go NT, what has to come next? Then what? S, then, and we know it's similar to, what's the N match up to in this other one? E? What's the T match up to? What's the H match up to? And on your homework, this is part of what you're going to have to do. And what's the S match up to? A, and then what's the V match up to? Z. So if we match them up, and again, when we look at the name, if I tell you angle N right here is 62 degrees, what other angle do you know? Angle E has to be what? 62 degrees. Yeah, fill in what you need to fill in on this. So again, scale factor, I'm not sure why I put scale factor on here like 15 times, but scale factor, side from shape 1 compared to side from shape 2. Be able to set up proportions 3 different ways there. You could have a proportion set up. The actual mathematical way to set up a proportion is this way. And the reason for it being this way is because you can do this. A and Y are your extremes because they're on the outside. B and X are your means because they're on the inside. And it sort of shows you the way to multiply them. To solve a proportion, most of you just call it cross multiplying. What you're actually doing, the actual rule, is to multiply the extremes together, set that equal to whatever the means is multiplied together. That's the actual rule. That's what they didn't teach you back in 4th, 5th grade, wherever it was. To multiply the extremes, multiply the means, then you put an equal sign in between those two answers. Again, if it's written out this way, so if it's something like 5:2 equals x:7, mathematically it's actually sort of easier. We don't have to do the little butterfly. You just say, all right, 5 times 7 is 35, and then you do the means, which is 2 times x, and you get 35 equals 2x. But most of you probably have seen it this way in the past, and so you cross multiply that way. Do me a favor because I forgot it. Draw a right angle in there. says if triangle ABC is similar to triangle FKH, you're going to match up the parts. And we're going to set up a proportion and solve for the missing sides and the missing angles. First, let's do the angles. We already did this one. What's this angle? 90. If angle A is 58 degrees, what other angle has to be 58 degrees? So write that in there. That angle right there, 58 degrees. How about angle C? We didn't know it. 32, anybody agree with that? How'd Logan get that? That all the angles should add up to 180, so 90 plus 58, subtract that from 180. If angle C is 32, what other angle is 32? So write that in there, 32 degrees. HK over here. I'm going to put it on top. It doesn't matter what goes on top really, but I'm going to put it on top. What's HK if we look here? HK, what's it match up to in the other triangle?
CB.
CB or BC. And so how long is BC or CB?
16.
So put that on bottom. So this matches up to that. Then we just got to match up two other sides. And we got to make sure if we put this triangle on top here, everything has to go on top over there. All right? So everything from this triangle has to go on top. So pick me another side in this triangle. KF. I'm just going to write KF instead of putting a variable there. You can just put a variable if you want. X, Y, Z, whatever you want. I'm going to put KF. What's KF match up to in the other one? Say it again, BA?
BA.
So that's 12, right? Then to solve that, we're just going to cross multiply. And most of you can probably do this in like just a step. You cross multiply, then what do you do with that number? Divide it. So we got 16 times KF. What's 8 times 12? 96. And then you're going to divide both sides by 16. How long is segment KF then?
6.
Anybody else get 6? Find the other one. If I'm doing this and I'm trying to find all the missing parts in any polygon, that 8 over 16 there, I just keep using it over and over and over again.
Can't we just do like Pythagorean's theorem?
You could do Pythagorean's theorem. I don't know that Pythagorean's theorem is any easier than setting up a proportion, but now what could make this easier, 8 over 6 actually reduces to what?
1/2.
1/2. So that might make it easier. You go ahead and reduce it down, and then when you're cross multiplying, the numbers aren't so big, and you don't have to do so much math. So we got 8 over 6. We're looking for HF, right? What's HF match up to in the other one? CA, is that right? What is that number? 20. So 20 goes on bottom. Now as Colton's doing this, he looks at it, because he doesn't like doing all the math. We've seen him many, many times in here. He doesn't like doing the math. You cross multiply and divide, do all that. He doesn't want to do all that. He looks at this and he says 1 compares to 2 the same as something compares to 20. What's going to go on top there? 10. Can you sort of see that without doing all the math? So how long is segment HF? 10. Did we find all the missing parts in both triangles? So if you can reduce it down and make it a little simpler on yourself, sometimes that makes it easier. two theorems. We're going to cover these two theorems. The first one's pretty easy. Fill in what you need to fill in on that one. You might want to put an asterisk or something out next to it. Instead of, if we're looking for the perimeter of the red shape, instead of going through and finding every side, then adding up all the sides, we could find the perimeter just by setting up one proportion. And that's what this theorem lets us do. Makes it a whole lot easier. Plus, when I guarantee on the next test, there'll be a problem like this, and about half of you are going to get points off because you're going to come up with something like this. 59.9 as the perimeter of the second shape. And it's not 59.9. It should be exactly 60. But as you go through and you set up and you find each side separately, you end up rounding stuff off. And then when you add them all back up, it doesn't come out exact. But if we use this, it comes out exactly what it should. So if I'm doing this on this problem here, we pick side from shape 1, this is shape 1, and we match it up to a side from shape 2. What's the only pair of numbers that we can pick that we can match up two pairs of sides?
3.
So here I'm going to put 8 over what?
I thought it was 3 over 8.
Does it matter?
Oh,
It doesn't make a whole lot of difference which way it goes. So if you wanted to do it 3 over 8, that's fine. You just have to make sure if you put 3 over 8, then you went from here to there. The way I went from here to there. So everything from this one's going to go on top, and everything from this one's going to go on the bottom. Somebody help me out. What's the perimeter of that first shape? How are you going to find the perimeter?
Add them all up.
Add them all up. So grab your calculator and do that real quick.
41.
What is it?
41.
41? Anybody else get that?
No, it's 45. I missed the 4.
45? Is that what we're going with?
Where is full center? Yes.
Where's your calculator at?
Is there a calculator?
So 45 goes on top. On bottom. Shh. On bottom. Put a P, something like that. What's the P stand for? Perimeter. So it's perimeter of the other shape. We cross multiply. When we cross multiply this way, what's that give us? AP. Cross multiply the other way, what's that give you? $135. Now what? Divide both sides by 8. What's the perimeter of the red shape? This one I don't think comes out even, does it?
16.9.
16.9. Anybody else get that?
Yeah.
16.9. How long is segment AE? Do we know? Do we care?
No.
No, all they asked us for was the perimeter, and that's our answer. How long is segment ED? We don't care. Now, could we have found each one of them by setting up a different proportion and matching up all these? Yeah. But if all they ask you for was the perimeter, then that's all you had to do. Next one, fill in what you need to fill in on this. A little tougher on this one. once you get the two formulas written down, circle the second one, because the second one's probably the one that you want to use. It seems to be a little easier for most students.
Why is it just up, Lucas? Why is it just up? It's not like running tags. Business Monday.
This is a good-looking young man, right? He's got to show it all. On this, to do this example, says triangle NTS is similar to triangle BLZ, and we want to find the area of triangle BLZ. All you're going to do is you're going to set up a proportion. A lot of the stuff that we're going to do over the next week or so. And you're just going to match it up this way. Area of the first shape compares to area of the second shape, side of the first shape, squared, side of the second shape. Do we know the area of the first shape?
Yeah.
What is it?
120.
So write 120 on top there. Do we know the area of the second shape? So I'm just going to put A to stand for area. Now here's where a lot of students get confused, or they forget. They just forget this little part. If you're dealing with areas, when we do the second part, you have to take the sides and square each one. So from the first shape, that's 10, but we don't just write 10 there. We got to write 10 squared. What side does it match up to in the second shape?
3 squared.
So 3 squared. Then the first thing I would do, if I'm doing this problem, leave that first thing the same, and you could probably do this. You didn't really have to do that first step. What is 10 squared? 100. What's 3 squared? So if you can do that, squaring those in your head might make it a little easier, less steps. Then we cross multiply. I cross multiply that way, what's that give me? 100A equals, cross multiply this way, what's that give you? 120 times 9.
1080.
1080?
Mm-hmm.
Everybody agree with that? Then what do? Divide both sides by 100. These cancel out, leaves you with A equals,
10.8.
what's our units? If we're dealing with area,
Centimeters.
centimeters squared. That's our answer. Now normally to find the area of that triangle, area of a triangle is base times height divided by 2. Do we know the base of that triangle? Do we know the height of it? We don't need to know it if we use this. Again, I would circle this one. It's easier to square each one of these separately than it is to do all that and square it all at once. So that second one's probably a little easier. Perimeter, I think you got all this on there already. I filled it in for you. Add up all the sides. Triangle, you might want to change this. I don't know why I keep putting it on there like that. Area of a triangle, we just wrote it down as base times height divided by 2. Next thing, what I want you to do, get out the sheet that you picked up there. We're going to start on it. So that sheet that you picked up, get it out. We should be able to get most of it done before you walk out.
Just everyone shut up and don't talk. Solve each problem. Oh, this is easy.
Number 1. Again, some of these, if you look at it, Colton looks at it, instead of cross multiplying and doing all the math, he looks at it, 8 over 4. How does 8 compare to 4? Or how does 4 compare to 8? Half. Alright? So what's going to go on bottom here? What is it, Andrew? If you can do it without doing all the math, I don't have any problem with it. If you start screwing it up, then I'll have a problem.
So does that mean we don't have to show all of our work?
Not on every one of them. No. Number 2. Now, here's where you get into trouble, because I guarantee I'm going to have somebody that's going to say, well, M is 3 because look how they match up. It doesn't work that way. All right? So this one, probably need to cross multiply. What do you get when you cross multiply that way? 3M. What do you get when you cross multiply the other way? Then you divide. Somebody tell us what M equals.
M equals 33.3.
33.3. Instead of 33.3, what's that 0.3 repeating as a fraction? 1/3. That's a better answer. So if you get that 3 repeating on your calculator, make it 1/3. Don't be afraid of the fractions. This time we cross multiply this way, what do we get? 7x, cross multiply the other way, what do you get? 18. Divide both sides by 7. How many 7s? Don't do it on your calculator. Is it going to come out even? So let's make it a mixed number. How many 7s will go into 18? 2. That's 14. So how many left over? So 2 and 4 7s. You can use the ABC button on your calculator and it'll do that for you.
Do you just want us to round to the 10th, right?
Let's see, I'd rather it was this way. We cross multiply here, what do you get there? 7x. This way. Dividing both sides by 7. And if you don't like doing it this way, the other thing you could do, and what I'm going to do on this problem, leave it as an improper fraction. Nothing wrong with leaving it 30 over 7. Now again, when they come out nice and even like this one's going to, if you can see what it's going to be, then just write it down. I don't have any problem with it. The way I look at this, I look at it going across this way. You got 2 here, you got 4 there. What do I do to 2 to get to 4?
Half.
Alright, so 4 to get to 2, you take half of it, right? I guess this one's not really going to come out even, but it's going to sort of. What's half of 9?
4.5.
4.5. 4.5. If you can see that, just write it down. If you can't, then do the cross multiplying and everything. Four?
Yeah.
Does everybody agree with that?
I don't know.
I think you went the wrong way, Colton.
No. I do it.
So look, Colton, think of it this way then. Watch. Do at least this. To get from 3 to 6, what do you gotta do?
Half. Oh.
Times it by
2.
2. So if we're going that direction, what do we gotta do to the 8? Times it by 2. What's A equal? 16. If you get confused, then you got to do the cross multiplying. You're gonna have to do cross multiplying on several of them like this one anyway, so. Here we cross multiply this way. What do you get when you cross multiply this way? 8n times 3. What's that give us? 24 n, right? Cross multiply this way. What's that give you? 64. Now what do we do? Divide both sides by 24. Somebody help me out with 64 divided by 24. .6 repeating. So what's that? 2 and what's that? 0.6 repeating. 0.3 repeating was 1/3. 0.6 repeating is 2/3. Cross multiply this way, what do we get? 9a. The other way. Divide both sides by 9. What's a equal? 3.8 repeating. Does anybody know what that is? We talked about this earlier this year. Anytime you get a number that's repeating, it's that number over what? 9. So that's the same as 3 and 8/9. Oops. It's supposed to say 3/8. This one, could you maybe do this one sort of in your head? What do you got to do to get from 2 to 8? Times by 4. So what are you going to do to the 13? Times it by 4. What do you end up with? 13 times 4. Maybe we shouldn't do it that way. We cross multiply, we get 2p equals, somebody help me out, what's 8 times 13? Nobody wants to help me anymore. 104. Then you divide both sides by 2. What is it? 52. Everybody agree with that? Cross multiply. What's 13 times b give us? 13b. Cross multiply the other way. What's 3 times 3 give you? Divide both sides by 13. Is 13 going to go into 9 evenly? So just leave it 9 over 13. On the back side, ignore that. 2 over n. Anybody see an easy way to do this one? Not, then we'll cross multiply. What's 10 times n give you? 10n. 2 times 12. 24. Divide both sides by 10. What's n equal? This one comes out pretty nice as a decimal, so what's the decimal answer? 2.4. 10 times R give us? 10R, 11 times 11. 121, divide both sides by 10. What's R equal?
Teachers, pardon the interruption. As we head towards the end of first block, I've had a couple announcements. There will be no football weightlifting this week. Enjoy your break off. Any girl planning to attend prom this year that needs help with a dress, please see Mrs. Dunn in the guidance hallway. Today's lunch menu is biscuits and gravy, sausage, hash browns, fruit and milk, hamburgers, and salad bar will also be available. Happy birthday today to Drew Rogers. Also, students, at the bell, we will release to second block, and then we will be releasing from second block to the high school gymnasium for our final Muse Machine performance of the year. Teachers, please hold until we have the okay to release. I will release like we normally do. I do ask the staff members sit in the bleachers with our students as well. Students, as always, we have guests in our building, and I expect all our actions to be above the line. Please continue to show people why it is better to be a Blazer with your behavior and your attention today as we have our final Muse Machine performance. With that, remember, each of you are a piece of the puzzle. Take all of us to complete that puzzle. Have a great Blazer Monday.
All right, look at 15 real quick. We got 4 minutes left. On 15 and on all the problems after 15. You see something like this top right here. Put parentheses around it. Then when we cross multiply, you're going to write it 10 times with the parentheses x minus 3 equals, and then on the other side we got just 9 times x, so 9x. Here we distribute, end up with 10x minus 30 equals 9x. Now what are you going to do? Subtract 10x on both sides. These cancel out. You're left with negative 30 equals, what's 9x minus 10x? Negative 1x. And then you divide both sides by negative 1. What's x end up equaling? 30. Don't make those harder than they are. Before you go anywhere, the packet up there in the very top of the little trays by the door. The packet's laying there. Grab one on your way out. As a matter of fact, I'm going to move it.
So we won't have a second block?
No, we
we'll
did
have
it during intervention.
Doing it during intervention.
It's weird.
Packets are laying right here. Grab one. That's the assignment.
Oh.
Plus finish this.
Second
Why
block.
did they do that announcement?
We're not having an intervention.
So we're going to go to second block, and then we'll go.
I'd rather not. Then why did it say we're releasing the second block?
You go to
We're going to second block.
How am I supposed to do it?
Yeah.
That's where you're going next. And then you go down to the gym, and then second block's
Look,
actually
grab me
a-
one too.
Yo, Cole, grab me one too.
So they'll change up the way the schedule goes for the day.
Well,